Alright guys, this is actually our only day of vector application. We're not going to do day 2. It gets a little bit more complicated, so we're just going to stick with day 1 since we're in this weird schedule right now. This is now just looking at real world situations that we could have used vectors to. So the first one says Susie is pulling her brother Bobby in a wagon using a force of 50 newtons. Which angle should the handle be at for the best result, 25 degrees or 55 degrees? So I'm just going to draw both vectors out first, but then we need to think about what this problem is asking us to find right now. So one of them is at 25 degrees, and we know we have the magnitude is 50, that goes on the hypotenuse. And then the other one is at 55 degrees, and the magnitude is 50, which goes on the hypotenuse. Now, this one doesn't directly tell us what we're looking for, but they want to know what the best result is. So I need you to think about, if you're pulling somebody in the wagon, what part of the triangle we really need to know to have the best result. What we're really focusing on is how far it would move, and that movement would be horizontal. So we would need to know this side, and then we would need to know this side. We're not worried about the vertical part for this particular problem, so we can just ignore it for this problem. And that's going to happen on a couple of the homework problems. Just pay attention to what they're asking you for. The first side, a lot of them you only have to find either the horizontal part or the vertical part, depending on which one they're asking you for. So since we're looking for x, we're going to use cosine. It's going to be cosine of 25 equals x1 over 50. And then we're just going to multiply by 50 on each side to solve for that horizontal component. And you should get that the horizontal component is 45.32, and then we're going to do the same thing on this side, but with its numbers. Cosine of 55 is equal to x2 over 50 times 50 times 50, and we get x2 is 28.69, no, 68. And then we're thinking about which one of those means it's a better result. This one means that that horizontal vector is going to go further. So this one goes further. That means that the 25-degree angle is the best result. Okay? And then here's the other type of problem you're going to see. This one is going to have more than one force going on. So if you imagine we have a situation where there is a toy and there's 3 dogs pulling on a toy. So we'll say this is like a ring toy right now. And one of them's pulling at 1 degree, one of them's pulling at another degree, and a third one's pulling at another degree, all at different forces. We want to know what the result is. Where is this toy going to end up if they're all pulling at different forces? So I don't draw these all together like I just drew in the picture there. I'm going to draw them separately first and figure out what all of the missing components are. So the first one was at 40 degrees, it's in quadrant 1, with a magnitude of 15 newtons. We're going to have to find x1 and y1 of that one. We're going to have to find all these component parts to resolve it, to find the resultant. And then the next one is 120 degrees, which is in this quadrant. That one's at 12 newtons. 120 degrees, 12 newtons. And we're going to call this x2, y2. And then the last one is 305 degrees, which is in the 4th quadrant. It has a magnitude of 8, and we're going to call this x3 and y3. So this is the first one we've seen that has 3 different vectors, but we're just going to do this the same way as we did the 2 force ones yesterday. So you're going to find each of the components. So now we just need to find the components for each vector. So in the first one, we'll do these in colors. In the first picture, to find x, we're going to do cosine. It's going to be cosine of 40 equals x1 over 15. And then I'm just multiplying that out on my calculator. We get 11.49. And then to find y, we're doing sine. Sine of 40 equals y over 15. Y1 is going to be 9.64. Then we need to do the second one. To find the second one, we gotta do cosine. Cosine of 120 is equal to x2 over 12. Find what x2 is. That's 12 times the cosine of 120, which is -6. And then it'll be sine of 120 equals y2 over 12. Should get 10.39. And then the last one, we're doing cosine of 305 equals x2 over 8. x3, whoops, 3. And you get 4.59. And then to find y, we've got to do sine of 305 equals y3 over 8. That's -6.55. So then from there, what they're asking us for is they want to know the magnitude and the direction of the resultant force. So to find the resultant vector, you have to add everything together. So all the x's are going to get added together first. I'm going to add all those numbers together to figure out what the resultant is. So the resultant horizontal component is 10.08i. And then I'm going to put all of the y numbers, all the vertical components together to find the resultant part for the vertical component. That's plus 13.48j. So that is the resultant vector. Then we have to find the two things it asks for. It asks for the magnitude. That's going to be the square root of 10.08 squared plus 13.48 squared. And you can just type that in your calculator. That comes out to 16.83, what we're measuring in newtons. And then we also have to find the degree. If you need to, if it helps you, you can graph out where our vector is right now. It's over, the horizontal point is 10.8, the vertical part is 13.4. We just found the magnitude, we're looking for theta. So we should be using tangent of theta, just make sure you do the right order. It's actually vertical over horizontal. It's y over x, just like slope, if you want to think of it that way. So then I'm doing tan -1 of 13.48 over 10.08 on my calculator to figure out what the angle is, which is just theta. And you get 53.2 degrees. That's the angle that the toy would be being pulled at. It's getting pulled mostly towards the one that had the strongest magnitude, the 15. That's in the direction that it's closest to being pulled, but not completely in that direction. It got pulled a little bit towards the 12 as well. But those are the two answers they're looking for. So I'd like you to do the homework and get it turned in before next class. And we will be doing an in-class assignment at the end of the week.